All right, so we're going to talk about composition of functions. You may also see this written as function composition, same thing. And so I want to go back to the idea of what a function is. In many ways, I like to think of a function as a machine that takes an input and then provides an output. So I want you to imagine if you had a function and we'll call this machine f right here. This is our f function, and it doubles something and then adds 1 to it. So if you put something in, if you take an x and you put it in, what you're going to get out is 2x plus 1. And I want you to imagine not only do we have a function called f, but we have another function called g. So this function right here is called g, and g triples something and then subtracts 4 from it. So I want you to imagine, and here's what composition of function is. Composition of functions is where you pass an input through one function, and then you take the result or the output and you pass that output through another function as the input of that second function. So you can imagine if we put in x originally, we would get 2x plus 1 after we put it through f, right? You double it and add 1. What's interesting here is when you start to stack functions on each other and say, okay, so now we have 2x plus 1. That's a thing now. I would like to now pass 2x plus 1 through the g function. The g function takes inputs, triples them, and subtracts 4. So let's think about this for a sec. What would happen to 2x plus 1 if we passed it through the g function? What is going to happen? So g is going to triple it, and then it's going to subtract 4. So let's do that. So we're going to triple the input, which I'm going to color the input now as 2x plus 1. That was the input. And then it's going to subtract 4. So if you did if you do f of x first, and then you let that be run through g of x, that's what we're doing here. So what we've got is we've done f of x on its own, and then f of x is now the input on the g function, right? So here's our g function. We always put the input right here. Okay, so this is going to be weird, but we took the output from f, which was f of x, and that's now the input, and we're putting it into g. That's what composition of functions is about. Okay, this is the notation that we use. We use something like g of f of x in order to denote function composition. Okay, so that's the idea. Let's do some examples with numbers first, and then go from there. Okay, so I want you to, let's actually just use the same f of x and g of x. So let's say f of x is 2x plus 1, and g of x is 3x minus 4. And let's say I asked you for g of f of 5. Okay? So g of f of 5. So what we're going to do here is, the way I want you to think about this is I want you to think of g as its own function, and I want you to think of f of 5 as its own thing. And so what we're going to do is we're going to evaluate, right? Hopefully you're used to that terminology. Now we're going to evaluate f of 5. So we're going to do g of, and then whatever f of 5 is, we know f of 5 is just a number. Then we'll put that red number in right here in this blank spot. Okay, so what is f of 5? So let's go up to f and think about it for a second. F's up here. If you plugged 5 in here, what would you get? Well, we'll actually write it out. So f of 5 would be what? It tells you double it and then add 1. Okay, so double it and then add 1. So f of 5 is just 2 times 5 is 10 plus 1 is 11. F of 5 is 11. So what we'll do is we'll put 11 in here. So we're basically, you can imagine if you think about the machine, right? So here's the F machine. We put in 5 into the machine. What came out of the machine? 11 came out of the machine. Now what we're going to do is we're going to run 11 through the G machine. So here's G. This was F. We're going to take 11 and feed it through the G machine. And what would we get on the other side if we did that? Well, what is G of 11? G of 11 is, it's going to be 3 times the input, subtract by 4. I'm just looking at the rule right here. G of x is 3x minus 4. So you triple it and then subtract 4. Okay. In our case, if you do 3 times 11 minus 4, that would be 33 minus 4. That would give you 29. So when you run 11 through the G function, what you get is 29 because the G function tells you to triple it and subtract 4. Okay. So what we're saying here is if you take 5 and you run 5 through the F function and then you take that result and run it through the G function, you should end up with 29. Okay? So that's G of F of 5. Let's do another one here. What would you get if you did G of F of 6? So this is going to be G of, and then we're just going to leave F of 6 in here. I'll make it blue this time. F of 6. Think of F of 6 as its own thing. So we'll have G of, and then in blue here, I'm going to write the actual number. What is F of 6? So if you think about it, F of 6 is going to be 2 times 6 plus 1, which is just 13. So F of 6 is 13. And now we're doing G of 13. What does G tell me to do to the inputs? So G says take this input, triple it, and subtract 4. So let's do that. We will triple 13, and then we'll subtract 4. So 3 times 13 is 39, minus 4 is 35. Okay, so G of F of 6 then is 35. Because what we do is we take 6, put it through the F function, we get a result, which is 13, and then we put 13 through the G function, and we get a result. Okay, that's composition of functions. I just want to do a few more examples with you guys and talk about a kind of weird case where you might look at a graph to figure out an answer. So let's do some more practice here. How about, let's say f of x is x squared plus 3, and g of x is 2x plus 7. And what if I asked you for g of f of 2? So this is g of f of 2. So I'm going to put f of 2 in red here. So what do we get? We get g of, what is f of 2 actually? So if we go back up to f of x here, what's f of 2? That would be 2 squared plus 3. Because all we're doing, look at what f is. F is a function that takes inputs and it squares them and adds 3. So we'll square our input and add 3. 2 squared is 4 plus 3 is 7. So f of 2 is just 7. So really what we're saying is to do g of 7. What is g of 7? What does g tell us to do? G is a function, so just come up, look at the rule. If you're not sure what to do and you're stuck, you're like, oh gosh, g of 7, just find your function, find the rule. The rule's right here. G of x tells us to do 2 times x plus 7. So it's just saying double it and then add 7. So let's do that. So if we double 7, I don't want a red parenthesis there. If we double it and then add 7, we get 14 plus 7 is 21. Okay, so g of f of 2 is 21. How about, why don't you pause, well, here, so let's do g of f of 4 Why don't you pause the video for a second and see if you can figure out what g of f of 4 is? Okay, seriously, pause it. See if you can figure it out. Okay, so I'm going to run through this here. So g of f of 4 is g of, and then we're going to put f of 4 here because that is its own thing. And that's going to be g of, what is f of 4 here? So let's come over to our f function. F tells us to square our input and then add 3. So f of 4 would be 4 squared plus 3. So that would be 16 plus 3. So that's 19. So this is just asking us to figure out what g of 19 is, which all you have to do is do double the input. This is what g tells us to do. It says double the input and then add 7 to it. So that would be 38 plus 7. So that'd be 45. Okay, so that's another example. Let's do another example. Okay, I'm going to make f of x 3x minus 5. And I'm going to make g of x 2x plus 3. And I want to know what g of f of 4 is. G of f of 4. So g of, and then f of 4 is its own thing. So I'm going to do that first. That's going to be g of, what would f of 4 be? Can we just figure this out? So f tells me to triple it and then subtract 5. So if I want to triple 4 and subtract 5, triple 4, 3 times 4 would be 12, minus 5 would be 7. So really what we're doing here is g of 7. G of 7 is 2 times 7 plus 3, which is 14 plus 3 is 17. Okay, now what I want to do is I want to start to talk about more difficult questions. Like, what if instead of asking you specifically, you know, a number here, like on this one I have 4, what if I just wanted to throw a generic x through there? So what if instead I asked you for g of f of x? And so now what I'm going to do is I'm going to put f of x here in orange because it's its own thing. And what we're going to do is we're going to do g of f of x. Let's actually just write down f of x. What is f of x? F of x is a function, and the output that you get from f of x is right here. It's 3x minus 5. So what we're going to do is we're going to put that in right here. We don't know what 3x minus 5 is like as a number. Like maybe it's 12, maybe it's 30. We don't know. But we can still apply the idea and the rule of functions and composition of functions even if we don't know the specific number. And this is what's so cool about algebra, and this is what makes it so useful in the real world, is when you have computer and software engineers, they don't know what people are going to type into the computer, and so they have to tell the computer, they have to teach the computer how to understand somebody's input. And so what they have to do is they have to say, hey, like whatever the user inputs, just triple it and subtract 5. That's a very weird example. I'm not sure if they would ever actually use that specific example. But this is a super important skill to have, like for computer programmers. Okay, so what is g of 3x minus 5? Okay, and this is where people have the hardest time because they're like, wait, what? G of x is 2x plus 3. How am I supposed to do g of 3x minus 5? And if you're struggling with this still, I want to bring you back to the idea of g of something goofy like yellow triangle. Okay, what's g of yellow triangle? And the answer is, well, just come over and look at the rule. The rule tells you what to do. G of yellow triangle is 2 times the input, which in our case is yellow triangle, and then you add 3. I'm just literally reading the rule right here. It tells us double it and then add 3. Okay, so if you want to know what g of 3x minus 5 is, then just follow the rule. Except the weird thing is that the input here is not x. The input is 3x, like the entire thing of 3x minus 5. But that's okay. Let's roll with it. So we're going to double that. So double 3x minus 5. And then add 3, because that's what g tells us to do. Literally all we've done is taken this rule and applied it when the input, instead of it being x, is 3x minus 5. Okay, so this up here, this was an x, but down here we don't want it for x. We want it for specifically the orange 3x minus 5. So we just take the orange 3x minus 5 and put it in there. Now, this is cool as an answer. I'm going to ask you, and most math teachers would ask you to simplify this. So you're going to need to multiply the 2 times the 3x to get 6x, and then the 2 times the negative 5 to give negative 10. Don't forget the plus 3 from above. And then we'll just simplify this. This will be 6x, and then minus 10 plus 3 would be minus 7. This right here is what happens if you take some generic x, run it through f of x, and then take that result, which is 3x minus 5, and run it through g of x. You would get 6x minus 7. And if you don't believe this, this is kind of cool. Check this out. Like, what I'm saying here is if you run a number through f of x and then you run that same number, or you take that output and run it through g of x, what you will get is you will get 6 times the original number that you ran through f of x, and then you would subtract 7 from that. And if you don't believe this, try it. Try it on like 6. Do f of 6 and then do g of that, right? So f of 6 would be, if you come up here, it'd be 13, and then do g of 13. I guarantee you that the original result would be 6 times the original input minus 7. So that's kind of cool. Let's talk about another weird example, which would be f of x. Okay, so now we've done g of f of x, but what if I wanted to know f of x? Okay, so I'll write it out for you here. So what if I wanted to know f of x? So I've got, basically, I'm going to take an input x, run it through f, and then take that output and run the output through f, through the machine, through the function again. Okay, so we'll say that this is going to be f of, and then let's color code f of x here. So let's take green. I haven't used green for a while. So f of x. So what we're going to do is we're going to say, okay, so this is equal to f of, and then I'm going to put in this green part here, f of x. What is f of x? Well, it's 3x minus 5. So 3x minus 5. So now the question becomes, what is f of 3x minus 5? Well, what does f tell me to do to my input? Be very careful here. Some people just put 3x minus 5, but that's not what this is asking. It's asking, if I put in this green 3x minus 5 as the input right here, what would I get? So the answer here is you're going to get 3 times the input minus 5. What is the input here? Be really careful. The input is not x. The input is 3x minus 5. And then you'll just have to simplify this. So this would be 9x minus 15 minus 5. So I got 9x from multiplying those two. I got minus 15 from multiplying those two. This is 9x minus 20. Okay? So that would be f of x. So what we're saying here is that if you took an input, x, ran it through f, then took that result and ran that through f again, it would be the same thing as just multiplying the original input by 9 and subtracting 20. Okay, last thing I want to do is look at some graphs and then talk about alternative notations, okay? All right, let's look at a graph. So we've got a graph here. And then what if they had asked you questions like these? So we'll just take these one at a time. So what if they ask us, using the graph, to determine what f of g of 2 is? So what would we say here? This would be f of g of 2. So what I'm going to do here is I'm just going to figure out what g of 2 is. Come over to the graph. What is g of 2? So what it's saying here is this is the input axis. This is the output axis. So we're going to input 2. So 2's right here. And the question is, if you look at the orange g of x curve here, I guess it's a straight line, but we usually call a function a curve. So what's g of 2? Well, if we're here at 2 and we come up, the curve's right here. And so what is the y value here? What's the output value here? It's 1. So g of 2 is just 1. So now the question is, what's f of 1? Well, just look at the graph and you'll be able to tell if you go over to 1 for f. So 1's right here. You come up. Here's the f curve. What's the output value here? It's 4. So f of 1 is 4. So what we're saying is that f of g of 2, according to this graph, is 4. Okay, so we'll just do some of these. So how about f of g of 6? So this is going to be f of, what's g of 6 here? So let's go over. On the input scale or axis, we'll go over to 6. What's the output that gets paired up with 6? It is 3. So that right there is 3. The y value is 3 there. So what we're doing is we're going to say that this is f of 3. And now the question becomes, what is f of 3? F of 3, well, if we go over to 3, we're now going to go up to the f function. Make sure you use the right function. This is the f function. So we're at 3. We're going to go up. And I'm going to say f of 3 happens to be 4. So that's interesting. F of g of 2 returned the exact same result as f of g of 6. Okay, next one. G of f of 5. So this is going to be g of f of 5. What is the output when you go over to 5 for f? So let's go over here. So we're at 5. We go up. What's the output here? The output is 6. Okay. So this is asking, what is g of 6? Let's go over to g of 6. So if we put input 6 for g, what's the output? I'm going to say it's 3. We'll do that in orange. Okay, so the output value is 3 there. All right, what is f of 2? So f of 2. So first of all, what is f of 2? If we come over here, 2 for the input, the output value is 3. So really what we're doing is we're going to switch f of 2 to 3 here. And now the question is, what is f of 3? So what's f of 3? If we come over to 3 for the input and we go up, the output value here is 4. All right, what about g of 5? So this is going to be equal to g of, and then let's figure out what g of 5 is and put it in this little blank spot right here. G of 5, so you'll come over here and we're at 5, and the question is, what's the output value when you're at 5? The output value there is 4. So this is really asking, what's g of 4? And let's look. So g of 4, so we're going to come over to 4. What is the output value when we're at 4? What's the y value that gets paired up with it? I'm going to say that that would be 3 right there. And then I have a kind of a doozy question here. What is this? There's so many f's. This is confusing to even read. What is f of 3? Okay. So what we're going to do is we're just going to go from the inside out. What we're going to do is we're going to start with this first. Then we'll work our way out. So I'm just going to write f of, and I'm just going to color code this, f of 3 here. I'm going to do that blue part first. Once I do the blue part, then I'll move on to the next f, this one right here. But we're going to do the blue first. Okay, so what is, all right, so we have f of, and then that blue part, I'm just going to put in a number there. What is f of 3? So if we go over to 3 here for the input, and we go up, what is our output? That's going to be at 4 there. Okay, so this is going to be f of 4. So now what I'm going to do is I'm going to take this right here and say, okay, I'm just rewriting this and color coding it for you so you can see this a little easier. This is asking what's f of 4. And so what I'm doing here is I'm just working from the inside out. All I've done is just change this f of 4 here to make it green so you can see it a little easier. Okay, so now what we're going to do is we're going to figure out what f of 4 is, and then we're going to plug that number in one more time into the f function. So let's go over to 4 on our input. If we go up to the output is 5 here. So f of 4 is 5. So what we've got is f of 5. And so now we can just finish. What is f of 5? So let's go over to our graph. So f of 5, so we're going to go over to 5 on the input and then go up to our f curve. F of 5 is right here. What's the y value there? It would be 6. So that would be 6. So f of 3 is 6. One last note on notation, then we'll be done here. So composition of functions, you may see it written like this. You may see f of g of x. Or some people like to write it f with a big open O. So it kind of looks like fog. These mean the exact same thing. So these are the exact same. Okay, you may see something like g of f of x, or you might see somebody write g and then a big O, f of x. Exact same thing. They just want you to do composition of functions. Remember that the one over here is the one that's on the inside of the parentheses. So f of x is the innermost function there. Okay, so for the reason I'm bringing that up is if you see something crazy like g of f of h of x, where you have 3 of them, you're going to interpret this as g of f of h of x. So you'll do the h first, then you'll do the f, then you'll do the g at the end. Okay, you always go from the innermost and then work your way out. And then the last comment I wanted to make is be really careful when you see composition of functions versus multiplying functions. So they look very similar. So one of them is an open dot and the other one's a closed dot. So if I have f o g of x like this, this right here is composition. This means you're going to do g of x first and then you're going to do f of that. So that's composition. This right here is multiplication. And so what you're going to do is you're going to find f of x, find g of x, and then multiply those two together. Okay? Just be really careful that slight difference between the open circle and the closed circle there. All right, that's it.